So two plane mirror 1 and mirror 2 are placed perpendicular to each other, and a ray of light is incident on mirror 1 at an angle of theta 1, which is equal to 37 degrees, and reflected off the mirror 1, and again it incident on mirror 2 and reflected back again at an angle of theta 2. Then what is an angle of reflection from mirror 2? That is theta 2. So to find the values of this theta 2, we use the concepts of reflection, the laws of reflection, which says that, let's assume that this angle is, let's say, beta 1, and let's say this angle is beta 2. We know that from the laws of reflection, theta 1 is equals to beta 1, or the angle of incident is equal to the angle of reflection. So if we know the values of theta 1, we know exactly the values of beta 1, which is 37 degree also. And then we know that if this angle is 37 degree and this angle must be, it's equal to, let's say, it is gamma 1. So from the geometry, if this is the normal of the plane from the mirror 1, so beta 1 plus gamma 1 is equals to 90 degree, and then I can find the angle gamma 1 from this diagram. So gamma 1 is equals to 90 degree minus beta 1, which is equals to 90 degree minus beta 1 is 37 degree, which is equals to 53 degree. So then, since the two mirrors are perpendicular to each other, gamma 1 plus, let's say this is gamma 2 and this is 90 degree, so we can see that from this triangle, that means if these are the mirrors and this is the ray light reflected off from the mirror 1, so this angle is, we have said it is gamma 1 and this is 90 degree and this is, we have said, gamma 2. So then from this, just easily we can see that gamma 1 plus gamma 2 plus 90 degrees equals to 180 degrees, since this is the right angle triangle. So gamma 1 is 53 degree, we have calculated. Then gamma 2 become 180 minus 90 degree minus 53 degree. So this is equals to 37 degree. So this angle is 37 degree, but beta 2 is equals to, beta 2 plus gamma 2 is equals to 90 degree. Then from the surface of mirror 2, just we can see that from, if this is mirror 2 and this is the normal, so this is theta 2 from the diagram, and this is beta 2, and this one is, we have said it is gamma 2. So then easily we can see that beta 2 plus gamma 2 is equals to 90 degree. So then beta 2 become 90 degree minus gamma 2, which is equals to 90 degree minus gamma 2 is 37 degree, we have calculated. So beta 2 become 90 minus 37 is 53 degree exactly. So then from the laws of reflection, we can say that beta 2 is equals to theta 2. Then theta 2 become the values of beta 2, which is 53 degree. So the correct answer for this question is on alternative D. So light refracts when it is passed from one medium to the other. So in this case, from air to the glass. We know that glass is more denser than the air. So if the light passes from the lighter medium to the denser medium, its speed reduces. Speed decrease means that the wavelength of the light also increases, but frequency remains constant. That means if the light is passed from the lighter medium to the denser medium, or it always bend toward the normal. If it passes from the denser medium to the lighter medium, bends away from the normal. So the refraction of the light is occurred due to the changing speed of the light. So the change in speed of the light in a different medium causes the refraction of a light. So the correct answer is on C, which says light travels slower in a glass than in air. So the correct answer is on alternative C. Refraction of light from one medium to the other, when it passes from one medium to the other, is occurred due to the change in speed of the light. So a light pass from area of refractive index 1 to the glass of refractive indexes N2 is equals to 1.6. Then it is obvious that if the light pass from the air to the glass, always it bends or it refracts toward the normal. So if the values of the incident angle theta is 53 degree, what will be the angle theta 2? So we can find this by using the laws of refraction, or what we call the Snell's law. Snell's law states that the refraction index of the medium 1 times sine of the angle of the incident is equals to the refractive index of medium 2 times sine of the angles of the refraction. This is the angle of refraction beta 2. So this is what we call the Snell's law. So if I substitute directly the value, n1 is equals to 1, since it is air, times sine of theta 1 is 53 degree. This is equals to 1.6, which is the refractive index of the glass, times the sine of beta 2. So if I rearrange this is 1 times sine of 53 is 0.8, which is equals to 1.6 times sine of beta 2. So this number become 0.8 over 1.6, which is equal to sine of beta 2. So from this, just we can say that the sine of beta 2 is equal to 0.8 divided by 1.6 is, this is 0.5, this is half exactly. So beta become, angle beta 2 become the sine inverse of 0.5, which is equals to 30 degree. But we know that the required angle is not beta 2. We can find beta 2, but beta 2 plus theta 2 is equals to 90 degree. So I can find the angle theta 2, since the question requires not beta 2 but the angle theta 2. So we know that this is the normal, and we have calculated this angle beta 2, and this is angle theta 2. So from this diagram, just we can see that theta 2 plus beta 2 is equals to 90 degree. So this means that theta 2 is equals to 90 degree minus beta 2, which is equals to 90 degree minus 30 degree, which is equal to 60 degree. So the angle theta 2 required is theta 2 is equals to 60 degree. So the correct answer is on alternative B. So electromagnetic wave is produced by A, steady current, B, electrostatic field, C, any moving charge, D, any accelerating charge. So it is obvious that electromagnetic wave is produced from the oscillation of electric and magnetic field. So if electric and magnetic field are continuously changing, or if they are oscillating, they produces what we call the electromagnetic wave. But changing electric field is always produces the magnetic field according to the Faraday's laws of electromagnetic induction. So the magnetic field produced by a changing electric field is itself is also changing continuously with time. So this means that the changing electric and magnetic fields are produced by alternating currents, or if the current is continuously changing with time. From this we can see that steady currents cannot produce electromagnetic wave. So the current must be continuously changing to produce a changing electric field. So the changing electric field also produce a changing magnetic field according to the Faraday's laws of electromagnetic induction. Electrostatic field cannot also produces the electromagnetic wave, because electrostatic means if the charge is at rest, means we don't have a magnetic field, so we have only static field. That means it cannot produces electromagnetic wave. Any moving charge cannot produces also electromagnetic wave. Moving charge produces electromagnetic wave only if they are accelerating. That means if the velocity is changing with time. That means if there is a change in velocity, the moving charge can produce electromagnetic wave. But this statement is not always true. It's only true if the velocity of the charge is changing or the charge is moving with some acceleration. So the correct answer is electromagnetic wave is produced by any accelerating charge. So the correct answer is on alternative D. To test the laws of reflection, a physics student sends a beam of light onto a plane mirror. He then measures the angle of incidence theta I as shown in the figure below. So, which of the following possibly indicate the result of his measurements, where theta are reflected angle? So, from the laws of reflection, it's easily known that the laws of reflection says the incident angle is always equal to the reflected angle, or angle of incidence is equal to the angle of reflection. So, the correct answer is exactly on alternative B, which says that theta I is equals to theta R.
Refraction is a bending of light as it passes through a small gap. Now this means if the light passes through the smaller gap or narrower gap, it becomes diffracted or it is spread out. B, change in intensity of light as it crosses boundary between two transparent media. No, it's not the change in intensity of the light. C says bending of light as it crosses the boundary between two transparent media. So this is exactly the definition of the refraction. The bending of light as it crosses the boundary between two transparent medium is what we call the refraction of the light, or bending of light when it passes from one medium to the other. This says the change in frequency of light as it crosses the boundary between two transparent medium. But if the light passes from one medium to the other, the frequency of the light do not changes or never changes. Only the speed and wavelengths of that light will change. So the correct answer or the definition of the refraction is on alternative C, which says the bending of light when it crosses the boundary between two mediums. So the correct answer is on alternative C. Question number 17 says, which one of the following is not the consequences of refraction? So refraction has some application. How the image is formed by the lenses are due to the refraction of the light that is one of the application. So A stick immersed in water appears to be broken. Yeah, it is the effects of the refraction or consequences of the refraction. B says the formation of image by mirror. Formation of image by mirror is not due to the refraction, it's by the reflection of light. C says the apparent depth of water is smaller than the actual depth. The object is under the water. It appears more nearer than it actually is. This is due to the refraction of the light. And D says the star looks higher in sky than it really is. This is also the skies. The image we see at the night from the sky it's not exactly the star. We see the light from the star and it appears more far or more higher than the star is actually is due to the refraction of the light when it is passed from the different layer of the atmosphere. So the not consequences of the refraction is alternative B, which says the formation of image by mirror. Question number 18 says, which of the following makes electromagnetic waves different from mechanical waves? So electromagnetic waves are, first, they are formed due to the oscillation of electric and magnetic field, and also we can say this statement is as the accelerating charge produces electromagnetic wave, and electromagnetic waves are always transverse waves and they come passing through the vacuum and also through the medium. But what makes the electromagnetic wave from other mechanical wave is they travel with the same speed in all medium. Now this means the speed of light or electromagnetic wave change their speed when they pass from one medium to the other depending on the density of the medium. B says they travel through material medium. Yeah, it is true, but all waves, even mechanical wave, can do that. C says they are transverse wave. So electromagnetic wave are transverse, but some mechanical waves like a ripple on water surfaces or the wave on the strings are also transverse wave. So both electromagnetic and mechanical waves are exhibit these properties. The only answer which the electromagnetic wave share is on alternative D, which says they travel through vacuum. Only electromagnetic wave can do this one. Mechanical wave cannot pass through the vacuum because mechanical waves are due to the oscillations of the physical medium. Mechanical wave cannot pass or travel through the vacuum. They always need the medium. That is what makes the electromagnetic wave different from mechanical wave, because electromagnetic wave can travel through vacuum.
If the object is placed in front of a concave mirror with a focal length f is equals to 30 cm at a distance of 80 cm, then we know that the object is placed behind the center of curvature, because if the focal length is 30 cm, center of curvature is twice of the focal length, which is 60 cm. So the object is placed behind the center of curvature of the mirror. So if the object is placed behind the center of curvature of the mirror, the image formed always between the point of center of curvature and the focal point is between these 2 points. So this image is always real. It's inverted, minimized, and formed between the center of curvature and the focal points of that mirror. So if the focal length of the mirror is 30 cm and the object distance is 80 cm, we can find the image distances by using the mirror equation. So mirror equation says that 1 over the focal length of the mirror is equals to 1 over the image distance plus 1 over the object distance from the mirror. So by rearranging, 1 over the image distance is equals to 1 over the focal length minus 1 over the object length, which is equals to 1 over 30 cm minus 1 over 80 cm. So if you rearrange this number and place exactly, the image distance is equals to 48 cm. Image distance is positive. Positive means the image is always real images. The image distance is equals to 48 cm and the nature of the image is the real images. So the correct answer is on alternative A. So an observer looks into a water tank which is filled with water. If the height of the tank is 200 centimeter, this is 200 centimeter. So this 200 centimeter is what we call the actual depth of the water, is 200 centimeter, or it's 2 meter. So if we look at the objects which is at the bottom of this water, it's appear that this object is more nearer, or it's look like the object is somewhat nearer to where actually it is. So if we look at a light ray coming from the objects, so water is more denser than the air. The light ray coming from water to the air is bends away or refracts away from the normal always. So if somebody looks at these objects, it's look like this ray of light is coming from this point, not coming from this one. It's look like that. So this object looks it is more nearer than it actually is. So this is what we call the apparent depth, not the real depth of the object. So 200 centimeter is the real depth of the water. So to find the apparent depth is always equal to the real depth times the index of refraction of air divided by index of the refraction of the water. So if I substitute the value directly, real depth is 200 centimeter times the index of refraction of the air is 1 divided by index of refraction of water is equal to 4/3 directly. So if you rearrange this number, this is 200 centimeter times, so this is inverted 4/3. So if you do this number exactly, you get that 150 centimeter. So the object looks like it is at a distance of 150 from the top of the water or from the surfaces of the water. So the apparent depth of the object is 150 centimeters. So the correct answer is on alternative D.
Okay, this question says, question number 21. Suppose a triangular object is placed in front of plane mirror and its image is observed at point X. Which one of the following diagram represents the image I formed by the mirror when it is observed from the position X? So if object O is placed in front of the plane mirror, then the image formed is always its virtual image erected and has equal height and equal distance as the object is from the mirror itself. But the only change occurs in image formed by the plane mirror is the lateral inversion, what we call the lateral inversion. That means the left and right side of the object and images are totally reversed. So if we look at the image from point X, exactly if this is the object and this one is the image, the correct answer or the correct diagram which represents the image formed by the plane mirror is exactly on alternative A. All alternative B, C and D are impossible. So the only answer is on alternative A.
Object is placed at a distance of 25 centimeter means that the focal length of the mirror is 10 centimeter. This is 10 centimeter focal length of the mirror from focal point up to the vertices or P of the mirror. Then we know that if the object is placed beyond the center of curvature, this is the position of the object is beyond the center of curvature, because if the focal length is 10 centimeter, the center of curvature is twice the focal length of that mirror. So this is the point of the center of curvature is equal to 20 centimeter, but the object is placed at 25 centimeters, so it is behind the center of curvature. So if the object is placed behind the center of curvature of the concave mirror, the image is always formed between the center of curvature and the focal points of that mirror. So the image formed is always, it is real, inverted and minimized. That means the magnification is less than 1 since the image is. So to find the magnifications of the image or how much time the image is magnified, we use that the magnification is equals to the image height divided by the object height, or this is equals to the image distance divided by the object distance from the mirror. So we don't have any information about the height of the image and objects, so we use the concepts of the image distance and the object distance. But object distance is given 25 centimeter and the focal length of the mirror is given 10 centimeter, but we don't know the image distances of the mirror, the image distance from the mirror. So from the mirror equation, we know that 1 over the focal length is equals to 1 over image distance plus 1 over the object distance from the mirror. So if we rearrange this equation, we get directly 1 over the image distance is equals to 1 over focal length minus 1 over the object distance. So 1 over the image distance is equals to 1 over focal length is 10 centimeter minus 1 over the object distance is 25 centimeter. And if we rearrange this number directly, we get that this become 15 over 250 centimeter. So then if we divide this number directly, we get that the image distance is equals to 250 centimeter divided by 1/5, which is equals to 16.67 centimeter. So then the magnification is equals to m is equals to the image distance divided by the object distance, which is 16.67 centimeter divided by 25 centimeter. The centimeter cancel with the centimeter, and we have left with 16.67 divided by 25 become 0.67 approximately. So the magnification is less than 1. This means that the image is minimized, or the size of the image is less than the size of the object. So this is the nature of the image formed by the concave mirror if the object is placed behind the center of curvature. So the correct answer for this question is on alternative A. So a light ray is passed from air to the water. So it is obvious that the refractive index of the air is less than that of water, or water is more denser than the air. So if the light passes from air to water, it always bends toward the normal, and the speed of light will reduce in this medium. Let's say this is if the air has a speed, the light has a speed VA in air and VW in water. So we know that the speed of light will reduce in a denser medium than in a lighter medium. So from the definition of refractive indexes, we know the refractive index of the air is equals to speed of light in vacuum divided by speed of light in air, and the refractive indexes of the water is equals to speed of light in vacuum divided by speed of light in water itself. So if I rearrange this equation directly, I get that refractive index of air times the speed of light in air is equals to refractive index of water times the speed of light in water. So then the speed of light in water can be calculated as the speed of light in water is equals to refractive index of air, speed of light in air divided by the refractive index of water. So this is equals to 1 times refractive index of air is 1, and the speed of light in air is simply, let's say, VA, and refractive index of water is 4 divided by 3, or if this is arranged, this become 3 over 4 VA. Or I can say that the speed of light in water is equals to 0.75 times the speed of light in air. This is one possibility we have. So from Snell's law, we have the refractive index of the air times sine of the angle theta 1. That means from the Snell's law, we have theta 1 is the angle of incidence and theta 2 is the angle of refraction or the angle of transmission. So by using the Snell's law, refractive index of the medium 1 times the sine of angle of the incidence is equals to refractive index of the second medium, which is water, times the sine of theta 2, which is the angle of refraction of the light. So then the sine of the angle of refraction, sine of theta 2, become NA, that means refractive index of air times the sine of angle of incidences divided by the refractive indexes of the water. So this is equals to 1 times the sine of theta 1. The sine of theta 1, which is 30 degrees, is given theta 1 divided by refractive index of the water is directly equal to 4/3. So if we rearrange this number, sine of theta 2 become, so then this number become 1 times sine of 30 degrees 0.5 divided by 4/3, means simply times 3/4, and this number becomes 0.375. So approximately we can say sine of theta 2 is approximately equal to 0.38. So among the given alternatives, D is the correct answer.